Dimensional modeling was developed by Ralph Kimball, comprised of facts and dimensional tables. Dimensional model is data structure technique optimized for data warehousing tools. A dimensional model is designed to read, summarize, analyze numeric information like values, balances, and counts in the data warehouse. Okay na.
As a data analyst, we should first learn what are the elements of dimensional data model. There are 5, which are fact, dimension, attributes, fact table, and dimension table. For easy understanding, let me give you a practical example. For instance, you are in the sales team and this time, you and your team are going to calculate this quarterly sales number of the given business process. The element fact here is the quarterly sales number as the measurement. For dimension, it gives who, what, where of a fact. So for our example, customer name for the question who, Makati City for location just for an instance, and the product name for what question. Whenever we say attributes, these are used to search, filter, and classify facts. In our location attributes, we can classify it whether what state or country it belongs, zip code, and such. 2 more elements are fact and dimension table. Fact table is the primary table in dimensional model. It contains measurement or fact and also foreign key to dimensional table. On the other hand, the dimensional table contains dimensions of a fact. It offers descriptive characteristics of the facts with the help of attributes.
There are steps to create a dimensional model. The first one is identify the business process, identify the grain, identify the dimensions, identify the fact, and the last one is build the schema. The first one is identify the business process. It is the most important step in creating a dimensional modeling because a failure here will have a cascading and irreparable defects.
Step 2. Identify the grain. The grain describes the level of detail for the business problem or solution. It is the process of identifying the lowest level of information for any table in your data warehouse.
Step 3 falls for identify the dimensions. All of the dimensions which are nouns like date, store, inventory, and such should be stored. For example, the date dimension may contain like a year, month, and week day. Fourth one is identify the fact. This step is co-associated the business users of the system because this is where they get access to data stored in a data warehouse. Remember, this is where we keep the measurements. Characteristic of fact table. The first one is concatenated key. Data grain, fully additive measures, semi-additive measures, sparse data, they generate dimensions.
The last step, build schema. In this step, you implement the dimension model. A schema is nothing but database structure. There are 2 popular schemas. Number 1, star schema, and number 2, snowflake schema. The star schema architecture is easy design. It is called star because the diagram resembles a star, with points radiating to the center. And the center consists of the fact table, and the points is dimension tables. And the snowflake schema is an extension of the star schema. In snowflake schema, each dimension is normalized and connected to more dimension tables.
Benefits of dimensional modeling. The first one is standardization of dimensions allow easy reporting across area of the business. And dimension tables store the history of the dimensional information.
And one of the benefits of using dimensional modeling is it allows to introduce the entirely new dimension without major disruptions to the fact table. And also, it also designed to store data in such a fashion that is easier to retrieve the information from the data, and that data is stored at the database.
There are 2 special performance techniques in the star schema, and that is star join and star index. The star join is a high-speed, single-pass, parallelizable, multi-cable join. It can join more than two tables in a single operation. This special shim boosts query performance. The second one is the star index. The star index is a specialized index to accelerate the join performance. These are indexes created on one or more foreign keys of the fact table. These indexes speed up joins between the dimension tables and the fact table.
When we talk about the advantages of the star schema, you find that it's simply a relational model with one-to-many relationship between each dimension table and the fact table. What is so special about the arrangement of the star schema? Why is it declared to be eminently suitable for the data warehouse? What are the reasons for its wide use and success in providing optimization for processing queries? Although the star schema is relational model, it is not a normalized model. The dimensions table are purposely denormalized. This is a basic difference between the star schema and relational schema for OLTP systems. However, the advantages far outweigh any shortcomings. So let us go over the advantages of the star schema. First is easy for users to understand. The star schema reflects exactly how the users think and need data for querying and analysis. They think in terms of significant business metrics. The fact table contains the metrics. The users think in terms of business dimensions for analyzing the metrics. The star schema emerges as a clear winner because of its simplicity. Users understand the structures and the connections very easily. Second is optimizes navigation. In a database schema, what is the purpose of the relationships or connections among the data entities? The relationships are used to go from one table to another for obtaining the information you are looking for. The relationships provide the ability to navigate through the database. You hop from table to table using the join paths. A major advantage of the star schema is that it optimizes the navigation through the database. And lastly, most suitable for query processing. Let us see how the query will be processed. First, select the rows from the customer dimension table where the city is San Francisco. Then, from the fact table, select only those rows that are related to this customer dimension rows. This is the first result set of rows from the fact tables. Next, select the rows in the time dimension table where the month is January 2009. Select from the first result set only those rows that are related to this time dimension rows. This is now the second result set of fact table rows. Move on to the next dimension of product. Select the rows in the product dimension table where the product is product A. Select from the second only those results that are related to the selected product dimension rows. You now have the final result of the fact table rows. Add up the extended cost to get the total.
Star schema keys, primary keys. Each row in a dimension table is identified by a unique value attributed designated as the primary key of the dimension. The surrogate key are simply system-generated sequence numbers. They do not have any built-in meanings. Each dimension table is in a one-to-many relationship with a central fact table. If there are 4 dimension tables of product, date, customers, and sales representative, then the primary key of each of these 4 tables must be present in the order fact table as foreign keys.
Comparison, entity relationship diagram comprises one table per entity and it can minimize data redundancy. How about dimension mode?
Dimensional model is one fact table for data organization and maximize the understandability.
Another thing about entity relationship, it can optimize update and it has transparency processing mode.
While in dimensional modeling, it can optimize retrieve information and has a data warehousing model.
Guys, which of the two diagrams is better?
I got my model for the long way round and build schema for the way. And I sure would like some of this eventually, and will help you some more. What can you say? When you need it's all here. You're gonna benefit from this. You're gonna follow these steps. You're gonna follow these steps. Oh, you're gonna follow these steps. When we read, then summarize, we analyze numerics, like values, balances, counts and weights and anything. Oh, you have to follow these steps.